Hello students, this is Nilanjana Sanyal from onlinemathtutor.me and ePodashuna. Today we will be knowing about the factor theorem, its statement and its proof. Then we will be doing one or two sums related to the factor theorem. Okay, so let's start. This is the factor theorem. It says if p of x is a polynomial of degree n which is greater than equal to 1, means it can be a linear polynomial, it can be a quadratic polynomial, a cubic polynomial, or a polynomial of high degrees, and e is any real number. Real number means it can be a natural number, whole number, integer, fractions, rational numbers, irrational numbers. Then part 1 is if p of a is equal to 0, then x minus a is a factor of p of x. And the second part is if x minus a is a factor of p of x, then p of a is equal to 0. Coming to the proof, we know from the remainder theorem that p of x is equal to x minus a times q of x plus p of a, where p of x is the dividend polynomial, x minus a is the linear divisor polynomial, q of x is the quotient polynomial, and p of a is the remainder of the division. If you do not know about the remainder theorem, I would recommend you to watch my video on the remainder theorem. Okay, now coming to the part 1 proof. If p of a is equal to 0, if p of a is equal to 0, then this part vanishes. So p of x becomes equal to x minus a times q of x. Therefore, if we divide both the sides by x minus a, this linear polynomial, that is p of x over x minus a is equal to q of x. Since there is no remainder of the division, therefore x minus a is a factor of p of x. Now what is a factor? If I say what are the factors of 10, what would be your answer? Factors of 10. One, 2, because 10 is an even number, 5 and 10. How are we getting these 4 factors? Because if we divide 10 by 1, we get the quotient as 10 and we do not have any remainder. 10 by 2 gives the quotient as 5, no remainder. Similarly, 10 over 5, quotient is 2, no remainder. And 10 over 10 is a perfect 1 and again no remainder. So, when we get a number which can divide the given number leaving no remainder, then we say the number that we are dividing with to be a factor of the number which we are dividing. Similarly, for polynomials, if a polynomial is divided by another polynomial and if we do not have any remainder of the division, then we call the divisor polynomial to be a factor of the dividend polynomial. So we are seeing that on dividing p of x by x minus a, we are not having any remainder. Therefore, we can say x minus a is a factor of p of x. So the first part has been proved. Coming to the second part. If x minus a is a factor of p of x, if x minus a is a factor of p of x, then p of x will be equal to x minus a times some polynomial of x. We are writing that as g of x. Then what will be the value of p of a? How can we get the value of p of a? We will be substituting a for x in this polynomial p of a. So p of a is equal to, in place of x we write a. So it is a minus a times g of a. And a minus a is equal to 0. Whatever may be the polynomial, this g of a, 0 times anything is equal to 0. Therefore, P of E is equal to 0. Therefore, we have proved the second part as well. Hence proved. Now, let us try to do one or two sums based on the factor theorem. Question 1. Find a factor of 2x cubed plus x squared minus 2x minus 1. Answer 1. Now, this is a cubic polynomial. First of all, let us write this as, say, f of x or p of x. Anything we can write. We can write this as p of x is equal to 2x cubed plus x squared minus 2x minus 1. Now we have to find a factor of this polynomial. We will be finding a linear factor which will be of this type. This is the rougher column. So x minus a should be a factor of this polynomial p of x, where we have to find the value of this e. In order to find the value of e, we will be arbitrarily taking some numbers and we will be putting them for x. And we will be finding the value of p of that number. So if x is equal to 1, we start with 1, a plus 1. So what is the value of p of 1? We put 1 wherever we have x. So 2 times 1 cube plus 1 squared minus 2 times 1 minus 1. And 2 times 1 cube is 2 plus 1 squared is 1. Minus 2 times 1 is minus 2 and minus 1, which is equal to 0. So P of 1 is equal to 0. We have got it straight away for the first attempt. So we have found the value of E. The value of E is equal to 1 because P of 1 is equal to 0. And what does the factor theorem say? It says that if P of A is equal to 0, then x minus a will be a factor of P of x. Therefore, x minus 1 is a factor of the polynomial 2x cubed plus x squared minus 2x minus 1. This becomes our answer. Whenever you have to find a factor of any given polynomial, you start with 1, a plus 1, then you may try minus 1, plus 2, minus 2. You take arbitrary numbers and put them in the place of the variable present in the polynomial and get the value of that polynomial for that value of x. If it is equal to 0, x minus that number will be a factor of the given polynomial. Okay? So let us move on to the next question. Question 2. Determine the value of a for which the polynomial 2x squared plus ax plus root 2 is divisible by x minus 1. So answer 2. Now let this polynomial be equal to p of x. P of x is equal to 2x squared plus a times x plus root 2. And this polynomial is divisible by x minus 1, means x minus 1 is a factor of p of x. And by the factor theorem, we can say since x minus 1 is a factor, therefore p of 1 should be equal to 0. Because if x minus a is a factor, then p of a is equal to 0 by the factor theorem. This is the rougher column. So over here we are having x minus 1 as the factor it is given. Therefore, p of 1 should be equal to 0. We first of all get the expression for p of 1 and we will be equating it to 0. So P of 1 is equal to 2 times 1 squared plus A times 1 plus root 2, which should be equal to 0 because x minus 1 is a factor of this polynomial. This implies 2 plus A plus root 2 is equal to 0. Or we can say A is equal to negative 2 negative root 2, or if we take this minus root 2 negative root 2 common, then we have root 2 plus 1 inside the bracket. We can either write the answer as A is equal to negative 2 negative root 2, or we can write A is equal to negative root 2 times root 2 plus 1. Okay, this becomes our answer. Now, before concluding, let me quickly give you another example related to the factor theorem, which I think will be beneficial for you to get a better understanding of this theorem. Let us first of all move back to the factor theorem page. Let us have a polynomial p of x equals x cubed plus 3x squared plus 5x plus 6, and we have to find a factor of this polynomial p of x. You can start with 1. I am taking this number minus 2, and we will be finding the value of p of minus 2. So p of minus 2 is equal to minus 2 whole raised to the power of 3 plus 3 times minus 2 whole squared plus 5 times minus 2 plus 6, which is equal to minus 2 whole cube is minus 8 plus minus 2 whole squared is a plus 4 times 3 is a plus 12. 5 times minus 2 is a minus 10 and plus 6. So minus 8 and minus 10 when added together will be giving us a minus 18 or negative 18, and 12 plus 6 is a positive 18. We get the result as 0. That is p of minus 2 is equal to 0. So if we relate these two, p of a is equal to 0 in this case, and we are having p of minus 2 equal to 0 over here. Therefore, we can see that a is equal to minus 2 for this polynomial. Now we have to get the factor of this polynomial, linear factor, which will be equal to x minus a. So what will be the factor? X minus of minus 2. A is minus 2. So x minus minus 2, which is equal to x plus 2. Therefore, x plus 2 is a factor of x cubed plus 3x squared plus 5x plus 6. This is the answer. So whenever you are required to find a factor, whatever is the value of a, in this case a is equal to minus 2. In question number 1 we had a equal to plus 1. Whatever be the value of a, if a is equal to plus 3, then if the variable present in the polynomial be x, then x minus 3 will be a factor of the polynomial. If it is a plus 3, change the sign, put a minus. First write the variable present in the polynomial, then whatever is the a value, just change the sign and write it. If it is a plus 3, write minus 3. If it is a equal to minus 5, write x plus 5. Whatever is the sign present over here, just change the sign and put it next to the variable present in the polynomial, and you will be getting the linear factor. Okay, this is the thing that I had wanted to say. So students, this brings us to the end of this session. Share this video with your friends if you think that they will be benefited by watching this video. Give this video a like and subscribe to my YouTube channel for more math videos every week. And you can also request for a video on any particular topic. Thank you for listening.